Hello everyone and welcome to this tutorial. Till now we have completed all the data pre-processing steps, and in this tutorial we have to find the optimal number of clusters, and to do that we will use elbow method. So let us begin. First we have to import the library. Go to sklearn official documentation, then API. Scroll down, here we have to look for this one, clustering, and we have to use this class k-means. So this is the class that we are going to use to determine the optimal number of clusters. And we have to import this class from sklearn.cluster. From sklearn.cluster, then import k-means. Execute. Now here we will write a code to determine optimal number of clusters. Define an empty list WCSS. WCSS means within clusters sum of squares. Then use the for loop for I in range 1, 20. So we will try 20 clusters, and out of these we will find an optimal number. Now define an instance of this class. K-means is equal to k-means. First we have to specify n clusters. By default it is 8. N clusters is equal to I. Then we have to specify this argument init. By default it is k-means plus plus. So we will specify the same. Let us understand this. This is the method of initialization init, and by default it is k-means plus plus. Now we have to train the model to find the optimal number of clusters. Copy this instance, paste, dot, fit, and in parentheses dataset. Now type WCSS dot append, and in parentheses we have to specify k-means dot inertia. Let us understand this. Go to official documentation, scroll down, go to attributes, then this one, inertia. This is the sum of squared distances of samples to their closest cluster center. So this is the main part that we have to do. Let us understand this again. First we have defined an empty list. After that we have defined a for loop, and within that for loop we have created an instance of this class k-means, and after that we are training the dataset. And at the end we are appending the results into this empty list. And this is the attribute to get the WCSS values. You can see the explanation here. Sum of squared distances of samples to their closest cluster center. Now plt.plot, specify range 1, 20. After that WCSS, then bx, then specify the title plt dot title, the elbow method, then xlabel plt dot xlabel, number of clusters, then plt dot ylabel WCSS, and at the end plt dot show, and execute. It will take a little bit time to execute. Great. So this is our output. So here you can see number of clusters versus WCSS, that is within clusters sum of squares. Let us determine the optimal number of clusters. We have to check the big change. This is around here. So we can select the optimal number of clusters 7, 8 or 9. Here I will select 8. This one. So this is how we can determine the optimal number of clusters with the help of elbow method. Now after determining the optimal number of clusters, we have to build a machine learning model. So add a new section, part 3, building the model. Here also we will use same class, k-means. Copy this. We don't have to import again, but I'll just specify here. Now redefine this instance. K-means is equal to, this is instance of this class, k-means. We have to specify number of clusters is equal to 8, and this is because we have determined optimal number of clusters is equal to 8. And to do that we have used elbow method. Then specify the init, this one, this argument, method of initialization. By default it is k-means plus plus, so we will use the same, k-means plus plus. And after that random state 0 and execute. So this is the instance that we have created, k-means. We have specified number of clusters is equal to 8. This is the initialization and random state. Now we have to determine dependent variable. Define a variable yk-means is equal to k-means, this instance, dot fit predict method and in parentheses data set. Let us understand this. First we have created an instance of this class, and after that we are using fit predict method. This method will train the model as well as return the dependent variable. Execute. Great. Now check yk-means. There are total 8 unique values in yk-means from 0 to 7, and these are the 8 different clusters. Yk-means dot n unique. So this method will not work here. Let us understand this again. First we have imported this class k-means, and we have imported this class from sklearn.cluster. And after that we have specified optimal number of clusters, initialization method and random state. And by doing that we have created an instance of this class. And after that we have used fit underscore predict method. Here we are training the model as well as we are getting the output. And output is this one, yk-means. So this will be the dependent variable. And there are total 8 unique values in this dependent variable from 0 to 7. That is 8 clusters. Let us get the output. Part 4. Getting the output. Add few cells. Check the shape of yk-means. Yk-means dot shape. So this is a vector. We want an array. Yk-means dot reshape length of the yk-means, comma 1, and redefine yk-means. Execute. Now check the shape again. Great. Now this is an array. Now define another variable b, np dot use concatenate method. First we have to specify yk-means. and after that df, and specify axis as well. Axis is equal to 1. Let us understand this. So this is the df. df is our original dataset before feature scaling. And here we are concatenating yk means and df, that is the results and original dataset. Execute. Get the columns df dot columns and execute. Great. Now define the final data frame. df underscore final is equal to pd dot data frame. First we have to specify data. Data will be b, this variable that we have defined. This is the concatenation of results, that is dependent variable and independent variables. And after that we have to specify the columns. First column is cluster number, and after that copy all these column names and paste and execute. Now check this final data frame. df underscore final dot head. Great. So this is the y variable, cluster number, and from second column this is our original dataset. Now for each observation we have a cluster. For this observation, cluster 1, that is second cluster. For this index 4, that is fifth cluster. For this cluster number 1, that is 0, and so on. We can store this in a CSV file as well. To do that, type df underscore final dot to CSV, and in parentheses specify the name segmented underscore customers and execute. Now go to files. Here you can see segmented customers. Download this. It will take a little bit time. Now show in the folder segmented underscore customers dot CSV and open. Great. Ignore the first column. So from this column balance up to end, this is our original dataset. And for each observation in this dataset, we have determined a cluster 1, 4, 0, 1, 5. So there are total 8 clusters from 0 to 7. For this observation, cluster number 2, that is index 1. For this observation, cluster number 1, that is index 0. Go to Colab notebook. So here we have successfully segmented the customers. Let us revise what we have done in this tutorial. First we have determined optimal number of clusters, and to do that we have used elbow method. Optimal number of clusters is equal to 8. After that we have trained the model, as well as we have predicted the dependent variable, this one. And at the end we have concatenated dependent and independent variables. And this is our final output. So this is all about the customer segmentation project. I will see you in the next tutorial. Till then, happy learning.